Now we're going to go over some triangle stuff. So this is card 69. A scalene triangle has no congruent sides or angles. So let's draw a picture of this. In fact, let's draw two pictures. We're going to do one with numbers and one without. Okay. So first, we can show that all the sides are different by giving them each a different hash mark, and we can show that all the angles are different by giving them each a different number of angle marks. So now if this was A, B, C, we could say that triangle ABC is a scalene triangle. Now you can also show this same idea using numbers, right? So we could say like this is 100 degrees and this is let's say 50 degrees and this is 30 degrees, and let's say this side is 20, this side is 15, and this side is 10. Let's call this D, E, F. So triangle DEF is a scalene triangle. Okay? That was card 69. This is card 70. An isosceles triangle has two congruent sides. The two congruent sides are called the legs, and the other side is called the base. The base angles, which are opposite the legs. So the base angles of an isosceles triangle are congruent. Alright, so let's see a picture of this. Again, I'm going to break this up into a picture with numbers and a picture without numbers. Okay, so let's say that this side is congruent to this side, but the base is going to be different. But the base angles, which are opposite the congruent sides, are congruent. So let's say this was triangle A, B, C. This is a leg. This is a leg. This is the base. And these are the base angles. Okay? And this top angle, which is different than the base angles, is called the vertex angle. Okay? So triangle ABC is an isosceles triangle. Now let's draw it using some numbers. So for example, let's say this is 70 degrees, this is 70 degrees, then this would be 40, and let's say that this length is 20, and this length is 20, and this length is 15. Let's call this D, E, F. So triangle D, E, F is an isosceles triangle. Alright? So that I think is good enough for this one. That was card 70. Now we're on card 71. And we're going to talk about an equilateral triangle. Has 3 congruent sides and 3 congruent angles that all measure 60 degrees. Okay? equilateral means all sides are congruent. Equiangular, well, let's not say congruent actually. Doesn't really matter, but let's say equal. Equiangular means all angles are equal. Let's split this guy up again into two sides. Okay. So, let's do an equilateral triangle as best as we can. Okay, so in an equilateral triangle, all sides are the same length and all angles are the same measure. So triangle ABC is an equilateral triangle. Now let's do an example of one with actual numbers. Okay, so let's say this is 60, this is 60 degrees, and this is also 60 degrees. And we can say this side is 10, and this side is 10, and this side is 10. So triangle DEF is an equilateral triangle. Alright, that was card 71. Card 72. An acute triangle has all angles let's do this one a little better. In an, we should capitalize acute, in an acute triangle, all angles are less than 90 degrees. Okay, so let's do a picture of this. Okay, let's say this angle is 50 degrees, and let's say this one is 60 degrees, and this one is 70 degrees. Okay, so, and let's say that this is A, B, C, so then triangle ABC is an acute triangle. Now I just want to go back to card 71, and we really should be capitalizing the names of these. So that's card 71. I'm going back to card 70 now. Going to card 69. Alright, that's good enough. Alright, so we're on card 73. Okay, a right triangle has one right angle. One angle is 90 degrees. Okay, let's draw a picture of this, which I'm sure you're familiar with. So triangle ABC is a right triangle. Okay, card 74. An obtuse triangle an obtuse triangle, has one angle that is greater than 90 degrees. Keep in mind that it is not possible to draw a triangle with more than one obtuse angle. Let's just go back to this right triangle. Let's say this angle was 50 and this one was 40 and that one was 90. Alright? So in this obtuse angle, let's just get an idea about how big this obtuse angle is. Alright, let's say this is about 140. So then we'll say there's 40 degrees left. So I'll give this one 25 and this one 15. Okay? And if this was A, B, C, then triangle A, B, C is an obtuse triangle. That was card 74. Okay. Card 75. An equiangular triangle has three congruent angles that all measure 60 degrees. Just see something real quick. Go back to card 71 and put an equilateral triangle is also an equiangular triangle. And then on this card we could say an equiangular triangle is also an equilateral triangle. So we would have this angle is the same at 60 to this angle, which also is 60 to this angle, which also must be 60, and all the sides are also congruent. So triangle ABC is an equiangular, and underneath it let's put end equilateral triangle. Yeah, that's fine. So that is card 75. The area of a triangle is A equals 1/2 base times height, where A stands for area, B stands for length of the base, and H is the height or altitude. Okay? Let's do an example of this on the back. Actually, we're going to do 2 examples. So we're going to split this in half, because there's really 2 important examples that we have to go over for this. Let's just draw your standard triangle. And let's say this is 10, and the length of this is 20. Then we can say area equals 1/2 base times height. Area equals 1/2 times 20 times 10. Area equals 100 units squared. The units of area are always squared. Centimeters squared, meters squared, inches squared, and so on. Okay? Now on the other side, you could have a triangle like this also, which sometimes confuses people. An obtuse triangle. So what happens here is the height is actually this dimension. So say this is 5 and your base is 10. So then area equals 1/2 base times height. Area equals 1/2 times 10 times 5. Area equals 25 units squared. Okay? And I believe that finishes up most angle and triangle stuff. Okay? Alright, so this last card on the area of a triangle was number 76. So now we're going to start talking about some more triangle information. Alright, this would be card 77. And the first thing is that the sum of the measures of the interior angles of any triangle is 180 degrees. Okay? And let's go on the back and draw a picture of this. This is something that you need to know at least probably 20 different times on the Regents exam. So if there's one thing you need to know on the Regents, I would say it's this. Alright. So let's just label this A, B, and C, and say angle A plus angle B plus angle C equals 180 degrees. Okay? That's card 77. Now we're going to be on card 78. Let's see what we got left. Okay, this is another important theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Okay, and this is extremely important. So this is very, very important, this one. Now, let's draw a picture of this. Okay, you see how we have this triangle here? Well, this angle out here, let's call it angle 4, and this is angle 1, and angle 2, and angle 3. Okay? First of all, angle 4 is an exterior angle. Now, angle 4 is equal to the sum of the two non-adjacent interior angles. You see how angle 1 is next to angle 4. Non-adjacent means not next to. So the two angles that are not next to angle 4 are 2 and 3. So it's equal to angle 2 plus angle 3. All right? Now, on the other side, let's write something else down. An exterior angle is greater than either of the non-adjacent interior angles. So that means that not only is this true, but angle 4 is also greater than angle 2, and angle 4 is also greater than angle 3. Okay? So, that's card 78. Let's go to card 79. Let me see. Okay. We're going to talk a little bit about isosceles triangle theorems. These are called the isosceles triangle theorems. If two sides of a triangle are congruent, and in parentheses let's put isosceles triangle, comma, then the angles opposite them are congruent. And let's see exactly what we mean. Okay, let's draw an isosceles triangle. So I'm going to make each one of these sides 2 inches. Okay, so say this is A, B, and C, and we know that this side is congruent to this side. Then what we also know is that the angles opposite those sides are congruent. Okay, so if AB is congruent to AC, then angle B is congruent to angle C. Alright, now we're on card 80. which kind of says a similar thing. If two angles of a triangle are congruent, and this is like in an isosceles triangle, then the sides opposite them are congruent. So comma, then these sides opposite them. You know what? Let's take out card 79 again. And we're going to put this on card 79 because it's almost the same thing. If two angles of a triangle are congruent, as also in an isosceles triangle, comma, then the sides opposite them are congruent. So in my picture I'm just going to draw a double-sided arrow to show you that you can go either way, and we can put if this then this, and we can also put if angle B is congruent to angle C, then AB is congruent to AC. So it works either way. Okay? So now I'm going to just redo card number 80. Okay? Let's see. Let's see here. Okay, now we're going to talk about triangle inequality theorems. Okay. The sum of the lengths of any two sides of a triangle must be greater than the third side. Okay? So, if we're going to draw a picture of this, right? Here's what we'll do. We'll draw a triangle. And this really goes for any triangle. Let's call this A, B, C, and let's say this side is 3, this side is 5, and this side is 7. So what this theorem says is that the sum of any two sides must be greater than the third side. So AC plus CB must be greater than AB. AC plus AB must be greater than CB, and CB plus AB must be greater than AC. Now let's show it in the numbers. 5 plus 3 must be greater than 7, which it is. 5 plus 7 must be greater than 3, which it is. And 3 plus AB is 7, must be greater than 5, which it is. Okay? That's what the triangle inequality theorem says. So let's look at card 81 now. In a triangle, the longest side is across from the largest angle and in a triangle the largest angle is across from the longest side. Just give me 1 second to check something here. Okay, so let's turn this over and let's draw a picture of this. I'm going to cut this in half. I'm not going to cut it, I'm going to separate the two sides with a line. down the middle. Okay, say we know, say this is triangle A, B, C, and we know the sides are 5, 3, and 7. Well, since 7 is the longest, side in the triangle, angle C, comma, across from it, comma, is the largest angle. Now we can also have something similar to this. Okay, again, let's call this A, B, and C. Let's say this is 70, this is 60, and this is 50. So, since 70 degrees is the largest angle in this triangle, segment AB, comma, across from it, comma, is the longest side. So AB is longest. And by the way, that also means that AC is second longest and CB is third longest, because it's across from the second longest side and the third longest side. Okay? So that's card 81. Let's just see what's next. Alright, this is card 82, and we're going to start talking about transversals and the angles that are formed there. Alright, so if two parallel lines are cut by a transversal, comma, the alternate interior angles are congruent. So, and then the other theorem we can say is that if two lines are cut by a transversal, and the alternate interior angles are congruent, comma, then the lines are parallel. Let's draw a picture of what this looks like. All right. So what we have is two parallel lines that are cut by a transversal. Remember, a transversal is a line that intersects other lines, like this. So, let's see. You could have 1, 2, 3, 4. And we'll put the feather mark on the line to show that they're parallel. And let's call this L1 and L2. So if L1 is parallel to L2, comma, then angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Okay? And this is the transversal. Alright, so that's card 82. Let's do card 83. If two parallel lines are cut by a transversal, comma, then the alternate exterior angles are congruent. And that means we can also say that if two lines are cut by a transversal, and the alternate exterior angles are congruent, comma, Then the lines are parallel. And this is card 83. Let's see a picture of this. Let's see. Let's go back to just this card for a second. This is card 82. I just want to put in a angle 1 would be congruent to angle 4, so I just want to put an angle mark on them. And angle 2 would be congruent to angle 3. Okay? Okay, so now we were doing alternate exterior angles, right? So that would be like so if L1 is parallel to L2, comma, then angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Okay? So those are the alternate exterior angles. Let's do card 84. If two parallel lines are cut by a transversal, the corresponding angles are congruent. If two lines are cut by a transversal, and the corresponding angles are congruent, comma, then the lines are parallel. let's just go back to card 83 and label this as the transversal. Alright, let's see. Let's do 1, 2, 3, 4, 5, 6, 7, 8. So, and let's label this L1 and L2, and let's say that these lines are parallel. So if L1 is parallel to L2, comma, then the corresponding angles are congruent. So angle 1 would be congruent to angle 5. Angle 2 would be congruent to angle 6. Angle 3 would be congruent to angle 7. And angle 4 would be congruent to angle 8. Okay? I think that's good enough for that one. Let's do 85. If two parallel lines are cut by a transversal, comma, the interior angles on the same side of the transversal are supplementary. If two lines are cut by a transversal, and the interior angles on the same side of the transversal are supplementary, comma, then the lines are parallel. Let me see something. Let me see something. If two parallel lines are cut there. Yeah, we're going to need to throw this card out and do a new one. So this is a new 85. If two lines are cut, if two parallel lines are cut by a transversal, comma, then any adjacent angles are linear pairs and are supplementary. Let's see. Okay. Let's see if we can add some more to this one. So if two lines are cut by a transversal and the interior angles on the same side of the transversal are supplementary, comma, then the lines are parallel. And let's see if there's anything else. Okay, well, that's good enough for this one. So, let's take a look again at what I'm doing here. Let's just also go back to 84 for a second and highlight transversal. So 1, 2, 3, 4, 5, 6, 7, 8. So if, and let's call this L1, L2, and this is our transversal. So if L1 is parallel to L2, comma, then the following angles are linear pairs and thus supplementary. Angle 1 plus angle 2 equals 180 degrees. Angle 1 plus angle 3 equals 180 degrees. Angle 2 plus angle 4 equals 180 degrees. 1 and 2, 1 and 3, 2 and 4, angle 3 plus angle 4 equals 180 degrees. Angle 5 plus angle 6 equals 180 degrees. Angle 5 plus angle 7 equals 180 degrees. Angle 6 plus angle 8 equals 180 degrees. And angle 7 plus angle 8 equals 180 degrees. And also, so let me see. If angle 3 plus angle 4 equals 180 degrees, and angle 5 plus angle 6 equals 180 degrees, then L1 is parallel to L2. Okay, that's enough for this card. That was 85. Now we're on 86. Vertical angles are congruent. So vertical angles are congruent. That means angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. Angle 5 is congruent to angle 8. And angle 6 is congruent to angle 7. Okay. Let's see now.